Alright, welcome everyone. My name is Kevin Libwit, and this is the first video of a series of training materials for Theiagen's Terra workflows for SARS-CoV-2 genomic analysis. In this first video, I'm going to be providing some background on the major bioinformatics challenges to SARS-CoV-2 genomic analysis and how we've addressed these challenges through the use of Workflow Development Language, WDL, or WDL, workflows in the Terra platform. And in the following videos, I'll be diving deeper into each workflow to describe their intended purpose, how they work, and of course, how to use them to help inform public health action. All right, so let's get into it. First off, it's important to frame this talk with the major bioinformatics challenges that public health labs are facing with regards to analyzing SARS-CoV-2 genomes. More labs now than ever have the capabilities of sequencing SARS-CoV-2 samples, but there are still major barriers to analysis. And I think broadly, these challenges can be categorized as genomic characterization, and I tend to define this as the assembly and characterization of single samples by clade and lineage type. This is, of course, a major requisite for our ability to track and understand the spread of variants of concerns. The next major challenge is the sharing of these data to internationally accessible databases such as GISAID and NCBI. Submission to these databases is critical to the international effort as it allows insights to be drawn about how the virus is spreading and mutating across the globe. The more freely available we can make these data to the international public health community, the stronger our decision making can be. And then the third major challenge is performing genomic epidemiology, analyzing groups of SARS-CoV-2 samples to infer phylogenetic relatedness as a proxy for epidemiological associations. The more we understand about genetic relatedness of SARS-CoV-2 samples, the stronger our epidemiological interventions can be. And so with these challenges in mind, we've turned to the Workflow Development Language, again, WDL or WDL, and the Terra platform to address each. For those unfamiliar, Terra is a bioinformatics web application that was developed by the Broad Institute in collaboration with both Microsoft and Verily Life Sciences. And there are tons of educational material on Terra, both technical details and tutorial walkthroughs on how to use this platform. But for now, I just want to provide the 1,000-foot view of Terra as a clean and intuitive web application that connects users to bioinformatics WDL workflows and dynamic cloud computing resources. I've been working in public health bioinformatics for the past 5 years, and two of the major challenges have always been, one, training laboratorians on how to use the bioinformatics software that I wrote, and two, accessing compute resources to support the use of these software. When I first started, I could write custom bioinformatics pipelines for analysis, but I was one of few people who could actually use them. That's because most public health scientists, as you all certainly know, are carrying an insane workload and don't have the bandwidth to learn command line interface and bash shell scripting to use the technical tools that I wrote. And on top of that, most labs didn't have the appropriate compute resources to even support such work. So what would typically happen is I'd write a tool and be so excited that things worked. And then I'd start to walk someone through how to use it, and I'd show them a screen like this. And there's a certain percentage of our public health community that sees something like this and get pumped. And they get excited to learn about how to start using these new technologies and want to start learning command line and interacting with things exactly like this. But unfortunately for most public health scientists, this is a brick wall. And again, not because most scientists can't learn this. I know for a fact that most public health scientists can. But as I said before, most public health scientists simply don't have the time needed to learn an interface like this. Well, Terra does away with all of that and instead allows public health scientists to interact with workflows that I build in a clean and intuitive user interface. So rather than this, Terra users have access to a web application environment of drop-down menus, graphics, pointers, and buttons that make analysis relatively straightforward. So rather than launching a terminal and pulling up Stack Overflow to run any of our tools, it's just the click of a button. And on top of that, Terra seamlessly connects to the user's Google Cloud resources so that they have access to practically limitless compute resources for their analysis. So, in summary, Terra connects users to both bioinformatics workflows and dynamic cloud computing resources. So, as soon as I write a WDL workflow for SARS-CoV-2 analysis, any public health scientist around the world can access it using the Terra platform. And so with that, let's talk about the WDL workflows that we have made available. So for genomic characterization and genomic epidemiology, we have the Titan workflow series. For genomic characterization, we have 4 Titan workflows to take data in from 4 different sequencing approaches, both paired N and single N Illumina data, Clear Labs read data, and ONT data. And for genomic epidemiology, we've made the Augur algorithm available through our Titan Augur Prep and Titan Augur Run workflows. And for sharing these data, we have our Mercury series of workflows that helps users prepare their sequence, assembly, and sample metadata for submission to both GISAID and NCBI databases. As I said at the top of the presentation, I'll dive deeper into each of these workflows in subsequent training videos, but for now, I want to focus on these workflows as a collection of workflows. So all of the workflows I mentioned on that previous slide have been organized and made publicly available through the Theiagen Public Health Viral Genomics GitHub repository. And it's this repository that is linked to the Theiagen DocStore account. So remember how I said that Terra grants access to WDL workflows? Well, DocStore is the platform that enables this. From DocStore, you can import WDL workflows into your Terra workspace and begin analyzing samples immediately. We will, of course, be releasing a training video on how this system works, but for now, it's important to know that our WDL workflows are publicly available through a single GitHub repository, and that this repository is linked to a publicly accessible DocStore account, meaning that everything I mentioned in these training videos are fully accessible through the Terra platform. And there is one more thing I want to note about our WDL workflows in this introductory video before diving deeper into each one independently, and that is the concept of versioning and GitHub releases. If you've already had an opportunity to use our workflows, you've likely seen multiple versions available to you in the Terra drop-down menu. And so I wanted to provide some context to our versioning system. So with our workflow versioning, we've adopted a 3-digit system to define major releases, minor releases, and patches made to the GitHub repository as a whole. So, for example, as of today, April 5th, 2021, our most recent release is version 1.3.2. So this versioning system indicates that we are within our first major release of the Public Health Viral Genomics repository, and that there have been 3 minor updates to version 1. And that within this 3rd minor release, we've issued 2 patches to fix reported bugs in the workflows. So as you all know, SARS-CoV-2 bioinformatics is a wildly dynamic field in public health right now. So in turn, we have been dynamically developing and releasing updated versions of our workflows, and will continue to do so as we further optimize these solutions. So if you see a new version available on your Terra workspace and are curious to learn more about each update, we make that information publicly available on our GitHub page here. And it's important to note that since all of our SARS-CoV-2 workflows are linked within the Public Health Viral Genomics repository, updates or patches to one workflow will be reflected in the version available for all workflows. So, for example, here you can see that a patch update was made in response to errors being reported with the Titan Augur Run workflow. But the updated version, v1.3.2, is the tag you'll see for every workflow that I mentioned, since they all are organized in a single GitHub repository. So if you're wondering which version to use for your analysis, a good rule of thumb is to use the latest release you see available, as it is the most up-to-date version. If you're at all hesitant about adopting the latest version every single time, you can read about the updates on our GitHub page to see if the changes made will impact the workflows you use, and from there, you can use your own discretion. The only hard advice I will give on which version to use is to not use the main tag, as this is reserved for our testing and development and not meant for routine analysis. All right, so that is it for this introductory overview of our Whittle workflows for SARS-CoV-2 genomic analysis. I hope that this was clear for everyone and that you were able to learn a little bit from this video. If you have any questions, please feel free to leave them in the comments below, and we will be sure to clarify as much as we can. Thank you, and I will see you in the next one.